Hello, everyone. This is Professor Oaks, and in this video, we are going to verify these trigonometric identities on the screen here. And so this won't be as extreme as the other video on verifying trigonometric identities, but these will still require a little bit of work. So for problem A, all right, so secant of theta times sine of theta equals tangent of theta. So I'm going to draw a line right down the middle and just pick one side to work on and then go from there. So first, then I will remember that one of the common strategies for verifying trigonometric identities is to change all of the functions to sines and cosines. So I'm going to rewrite that secant of theta as 1 over cosine of theta, and then we have times sine of theta. And then that's sine of theta, all right, over cosine of theta. So again, if you want to maybe write the sine of theta over 1 to make it easier for you, that's okay also. And then sine of theta divided by cosine of theta, that is tangent of theta, and therefore we see that the identity is verified. All right, so now let's look at problem B. All right, so we have, let's see, 1 plus cotangent squared of negative or theta or opposite theta, and that's equal to cosecant squared of theta. All right, so now this one might require a little bit of extra work for you, but but that's okay. All right, sometimes things in life require a little bit of extra work. All right, so one of the things that you probably should remember here is that the cotangent of theta here is an odd function. So what does that mean? It means that cotangent of the opposite of theta will equal cotangent of theta times a -1. So negative cotangent of theta. Oh, where is it? I'll write it. That would be the easier way to write it, wouldn't it? So the opposite of cotangent of theta, all right? So cotangent of theta is an odd function. So it has this property here. So that's using the even and odd identities, all right? So now another way to write this cotangent squared theta is 1 plus cotangent of the opposite of theta squared, but we see that that was by this even and odd identity here, the opposite of cotangent of theta squared. But then when I actually square the opposite of cotangent of theta squared, then I just end up with 1 plus cotangent of theta squared, or cotangent squared theta, all right? So, this whiteout again is really cheap here, so that's okay. So cotangent squared theta, and then 1 plus cotangent squared theta is equal to cosecant squared theta. That is a Pythagorean identity. So therefore, I see that this identity is verified. So therefore, the identity is verified. All right, so there you go. So there is problem B for you. All right, so let's move on to problem C. So far, again, we've had some basic like reciprocal or quotient identities. Then we use even and odd identities. We've used the Pythagorean identity. So there are just some sort of basic identities like this that are important to know. All right. So C. cosecant of theta minus 1 times cosecant of theta plus 1 equals cotangent squared theta. So I'll draw a line right down the middle again. And for this one, I think that my strategy is just going to be multiply and simplify first. So let's distribute here. So we have cosecant theta times cosecant theta, that cosecant squared theta, then plus cosecant of theta, then minus cosecant of theta, and then minus 1. And then we see that the cosecant of theta is 0 out. So we have cosecant squared theta minus 1. And then again, there's a couple of ways to visualize this, but one of the ways is to use the Pythagorean identity. And one of the Pythagorean identities is that cosecant squared theta is 1 plus cotangent squared theta. So 1 plus cotangent squared theta is the same as cosecant squared theta. Then here, the 1, 0 out, 1 minus 1, 0. So we're left with cotangent squared theta. And we see that that's the same on each side. So therefore, the identity is verified. All right. So there is problem C. All right. How about here, problem D? All right. 1 minus cosine squared theta times 1 plus cotangent squared theta. Does that equal a 1? All right, so there are, of course, a lot of ways that we can do this one also, but let's look at this one at a time. So 1 minus cosine squared theta. So if I have identities involving sine and cosine, right, then I know the 1 by the Pythagorean identities is sine squared theta plus cosine squared theta. And then we still have minus cosine squared theta. And then remember, we just did this in problem C, but 1 plus cotangent squared theta was equal to cosecant squared theta. So times cosecant squared theta. All right, and then the sine squared theta plus cosine squared theta minus cosine squared theta, and that factor, the cosine squared theta is 0 out. So we're left with sine squared theta times cosecant squared theta. And then I'll use my strategy of converting to sines and cosines. So cosecant squared theta is really a 1 over, right, a sine squared theta. Remember again that cosecant squared theta is cosecant of theta squared, and then cosecant theta 1 over sine of theta. And then when I square that, square the 1 squared of 1, and sine of theta squared is sine squared theta, all right? So you don't have to show this step over here, but if it helps you get this correct, then please do that. Then, like in problem A, I can write that sine squared theta over 1, and then the sine squared thetas divide out. So I'm left with 1 divided by 1, which is 1. And so now each side is equal to 1, and therefore the identity is verified, all right? So in any case, I really hope that you're enjoying this. So let's look at problem E now. So problem E, this is a tangent squared theta times cosine squared theta plus cotangent squared theta times sine squared theta. Does that equal 1? All right, so I am going to start by changing all of the functions to in terms of sines and cosines. So I have a tangent here and a cotangent here. All right, so I have tangent squared theta is sine squared theta over cosine squared theta, then times cosine squared theta, and then cotangent squared theta will be cosine squared theta over sine squared theta times sine squared theta. And then again, if it helps you visualize this a little easier, write the cosine squared theta over 1 and the sine squared theta over 1, and then divide out the cosine squared theta and the sine squared thetas. So we have sine squared theta over 1 plus cosine squared theta over 1, or just sine squared theta plus cosine squared theta. And we know that's a Pythagorean identity, and it is equal to 1. So therefore, the identity is verified. All right, so I hope that you enjoyed that one here. All right, let's try problem F. All right, so we have cosecant of v minus 1 over cosecant of v plus 1 equal 1 minus sine of v over 1 plus sine of v. So, of course, there are lots of ways that this can be done, but I am going to just start by the old trick of the past several problems of changing all of the functions to terms of sines and cosines. So cosecant of v, that's 1 over sine of v, so minus 1 or 1 over 1. And then we have a double fraction, so be careful for the to watch out for the double fraction, all right? And then the denominator, we have a cosecant of v plus 1, so that's 1 over sine of v plus 1, or 1 over 1. And then let's find a common denominator in the numerator and then in the denominator. So we see that in the numerator, it's a sine of v, so I'll multiply this by sine of v over sine of v. And here it's sine of v, so I'll multiply by sine of v over sine of v. So let's simplify here. So in the numerator, I have 1 minus sine of v over, all right, it's all over sine of v now. Then remember, I have a double fraction. So we have 1 over, 1 plus sine of v all over sine of v. All right, I kind of did not, I didn't write the step where I wrote it as 1 over sine of v minus sine of v over sine of v, and then all over 1 over sine of v plus sine of v over sine of v. But you could have written that in between this step and this step if you would have liked to. And then remember that when you have a double fraction here, that you need to make sure that you have parentheses around the numerator and the denominator, all right, because that fraction bar is a grouping symbol. And then you multiply by the reciprocal, so 1 minus sine of v over sine of v times sine of v over 1 plus sine of v. And then the sine of v's, those actually divide out here. Goodbye, right? So we have 1 minus sine of v over 1 plus sine of v. And we see that that's what this was supposed to equal. So therefore, the identity is verified, all right? So there you go. So I hope that you enjoyed that. But again, a lot of these, if you've noticed, have started out with me converting all of the functions to be in terms of sine and in terms of cosine. All right, problem G. All right, oh, here we go. G, sine of theta times cotangent of theta plus tangent of theta. Does that equal, or we're trying to show that it equals secant of theta? All right, so again, let's just go with the normal trick that I guess you want, if you want to call it that. It's not really a trick, more as much as it is a technique of changing all of the functions to be in terms of sine and cosine. So let's see, here we have cotangent of theta is cosine of theta over sine of theta, and tangent of theta is sine of theta over cosine of theta. And then you can either find the common denominator here first or distribute the sine of theta first. It really doesn't matter. So let's distribute this. So we have sine theta cosine theta plus, all right, that's over sine of theta, then plus the sine, all right, and sine theta times sine of theta, that's sine squared theta all over cosine of theta. All right, so now, usually, like I wouldn't divide something out midway, but if I divide that out, right, sine of theta over sine of theta of 1, in this term I have cosine of theta plus sine squared theta over cosine of theta. Then there's only a cosine of theta in the denominator instead of there being a sine of theta and a cosine of theta in the denominator. So if I write this cosine of theta over 1, then all I need to multiply by now is a cosine of theta over cosine of theta. So now the denominators are both cosine of theta. And then in the numerator, I have cosine of theta times cosine of theta, cosine squared theta, then plus the sine squared theta. But this is a Pythagorean identity. Cosine squared theta plus sine squared theta, or sine squared theta plus cosine squared theta, that is actually equal to a 1. Excuse me. So 1 over cosine theta, and that's a reciprocal identity, which is equal to secant of theta, which is what we were supposed to verify. So therefore, the identity is verified. All right, so let me backtrack for one moment, because if you want to see G another way, and I want to show it to you another way, whether you like it or not. So if you don't want to see it, just skip over this part. And so here, remember that one thing I said that I could have done was actually just, let's see, let me rewrite this here. I could have actually found the common denominator on the inside first. So sine of theta over sine of theta, and then cosine of theta over cosine of theta. Sorry, I wrote them on the wrong sides, but okay, so I wrote them on the wrong side. Unbelievable, because this is why I actually said something earlier about the fact that that's why I said something earlier about canceling out or dividing out these sines of thetas to make the denominator simpler. So don't write them on the wrong side like I just did, but here we go. So I'll write them again. So now the denominators are both going to be, right, sine theta, cosine theta. Then we have cosine of theta times cosine of theta, cosine squared theta, and then sine of theta times sine of theta is sine squared theta. Then that in the numerator is still a Pythagorean identity, which is equal to 1. So now we have sine of theta times 1 over sine of theta cosine of theta. And then if I write the sine of theta over 1, then I can see maybe a little bit more easily that the sine of thetas divide out. And so then I'm left with still 1 over cosine of theta, which is secant of theta, which I know is what I was supposed to verify. So again, it doesn't matter if you distribute that sine of theta right here first, or combine the like terms inside of the parentheses, but I went for this way because I saw that the denominator might end up being a little bit more simple to deal with. All right, let's look at problem H. All right, so problem H, here we go. So cosine of v over 1 plus sine of v plus 1 plus sine of v all over cosine of v equals 2 secant of v. All right, so remember that I know that I probably told you this at some point, hopefully. Well, I sort of I lost my marker cap, and I've been doing that a lot lately. Who knows why? All right. So if you have the 1 plus sine of theta in the denominator, that might be a good time to multiply by the conjugate. All right. So multiply by 1 plus sine, 1 plus sine of theta, and then time 1 minus sine of theta. So 1 minus sine of v in this case, because the variable is v. So that will take care of this term right here. But then what do we have then? All right, we have cosine of v times 1 minus sine of v all over. Let's distribute in the denominator. So 1 times 1, 1, then minus sine of v plus sine of v minus sine of v squared. So sine squared v. And then this is plus the 1 plus sine of theta, v or theta over cosine of v. So now here, the sine of v's zero out. So I'm left with, all right, what am I left with here? I'm left with cosine of v times 1 minus sine of v over 1 minus sine squared v plus 1 plus sine of v over cosine of v. Now, again, there's lots of ways that you can do this. So what I'm doing is just one way to go about this. But if I see a 1 here, minus sine squared of v, well, all right, well, I know that 1 is actually equal to sine squared v plus cosine squared v minus sine squared v, and then plus 1 plus sine of v over cosine of v. Then here we have that the sine of v's zero out. So we're left with cosine of v times 1 minus sine of v all over cosine squared v plus 1 plus sine of v all over cosine of v. But this cosine squared v is actually going to be cosine of v times cosine of v plus 1 plus sine of v all over cosine of v. And here I have a cosine of v that divides out. So I'm left with 1 minus sine of v over cosine of v plus 1 plus sine of v over cosine of v. But the great news about the way that I decided to do this problem is that both fractions here, or both the rational expressions here, have the same denominator of cosine of v. So I'm going to just add these together now. 1 minus sine of v plus 1 plus sine of v. Then the, well, I think you get the point, that the sine of these, right, the sine of v is zero out. So I have 2 over cosine of v, or 2 times 1 over cosine of v. Right, that's the same thing. And 1 over cosine of v is secant of v. And so therefore, the identity is verified because I wanted to show that the original expression was equal to 2 secant of v. So therefore, the identity is verified. All right. So again, there's lots of ways to do this, but this is just one of the ways to go about doing this particular problem here. All right, let's look at problem I. So I is 1 minus sine squared theta over 1 minus cosine of theta equals opposite of cosine of theta. So there's lots of ways that I could do this one, but I'm just going to write this over 1. So 1 over 1, then find a common denominator. So 1 minus cosine of theta, 1 minus cosine of theta. All right, and again, they're actually, you know what, there's, you know what, why don't we do it, you know, now that I say this, I think that we should just do this the same way that we did the last problem. So why don't we just do this the same way that we did the last problem? Not that it, again, will matter. It's just that I think that it will end up being a little bit quicker. So, right, if I multiply by 1 plus cosine of theta, the conjugate here, 1 plus cosine of theta, then in this denominator here, I have, all right, I have 1 plus cosine of theta minus cosine of theta minus cosine squared theta. Then the where'd my red one go? Unbelievable, right? The cosine, not cosine squared. This is unbelievable. All right, sorry. 1 plus cosine theta minus cosine of theta minus cosine squared theta. So the cosine of theta's zero out. So I'm left in the denominator with a, right, with a 1 minus cosine squared theta. Now remember that a 1, right, in terms of sines and cosines, is actually just going to be a sine squared theta plus cosine squared theta, and then we have minus cosine squared theta. So then the cosine squared theta zero out. So then we have 1 over 1 minus sine squared theta times 1 plus cosine of theta over sine squared theta. And now the sine squared thetas divide out. So I'm left with, all right, I don't even need to write 1 over 1 in this case because of the way that I end up doing this. So 1 minus 1 plus cosine of theta. Distribute this, all right, here. So we have 1 minus cosine of theta, and 1 minus 1 zeros out. So I'm left with a opposite of cosine of theta, and that's what I wanted to show. So therefore, the identity is verified. All right. So again, the strategies are all hopefully coming together for you in terms of how these are done. All right, let's look at J. All right, 1 over 1 minus cosine of x plus 1 over 1 plus cosine of x equals 2 cosecant squared x. All right, so for the first term here, why don't I multiply by the 1 plus, all right, cosine of x over 1 plus cosine of x, the conjugate. Here, 1 minus cosine of x, 1 minus cosine of x, the conjugate for this one. All right, so we have in the first term, 1 plus cosine of x all over 1, and plus cosine of x minus cosine of x minus cosine squared x, and then 1 minus cosine of x all over 1 minus cosine of x plus cosine of x minus cosine squared x. So the denominators are actually the same once I zero out the cosines of x. So I have 1 plus cosine of x over 1 minus cosine squared x plus 1 minus cosine of x over 1 minus cosine squared x. So now that the denominators are the same, I'll just write this all over 1 minus cosine squared x. So I have 1 plus cosine of x plus 1 minus cosine of x. And the cosine of x zero out. So 1 plus 1 is 2. So 2 over 1 minus cosine squared x. But remember, in terms of sines and cosines, that 1 is equal to, that will be equal to, all right, a sine squared x plus cosine squared x minus cosine squared x here. So then the cosine squared x's zero out. So I have 2 over sine squared x. And another way to write this is 2 times 1 over sine squared x. And that is, that's going to be cosecant squared x. So it's 2 cosecant squared x, and therefore the identity is verified. All right, verified. So I really hope that you're enjoying these and getting some sort of a handle on the general strategies to use here. All right. Oh, that was I. All right, we just did J. Let's do K. We have 4 more. All right, so K, cosine of theta over 1 plus sine of theta. Does that equal 1 minus sine of theta over cosine of theta? So what am I going to do here? Well, let's try multiplying by the conjugate. 1 minus sine of theta. 1 minus sine of theta, all right? So then in the numerator, I have cosine of theta times 1 minus sine of theta. If in the denominator, 1 minus sine of theta plus sine of theta minus sine squared theta. And then the sine of thetas actually zero out here. So I'm left with a cosine of theta times 1 minus sine of theta, then all over 1 minus sine squared theta. And then remember how I've been doing this in terms of sines and cosines. 1 is equal to, all right, 1 is equal to a sine squared theta plus a cosine squared theta minus a sine squared theta. In sine squared theta minus sine squared theta is 0. So I'm left with cosine of theta times 1 minus sine of theta all over cosine squared theta. But then cosine squared theta is going to be, all right, the same as cosine of theta times cosine of theta. So then the cosine of theta divides out, and then I'm left with what I was trying to verify. So therefore, the identity is verified, all right? So I want you to see that that there aren't too many things that could happen. This was another problem in a row where you can see that I used the strategy of multiplying by the conjugate. All right, L, problem L. All right, so secant of u minus tangent of u equals cosine of u over 1 plus sine of u. All right, so I'm going to try my normal technique of changing to all of the functions in terms of sines and cosines. So secant of u is 1 over cosine of u, and then tangent of u is actually sine of u over cosine of u. And now, if you look here, I have a common denominator. So I have 1 minus sine of u over cosine of u. But this is not what I wanted, right? But this time, I'm going to multiply by the conjugate, but I'm going to do that in the numerator. So 1 plus sine of u, and then 1 plus sine of u. So I have in the numerator, all right, 1 plus sine of u minus sine of u minus sine squared u all over cosine of u times 1 plus sine of u. But the sine of u zero out in the numerator. So I'm left with 1 minus sine squared of u all over cosine of u times 1 plus sine of u. And then again, remember my technique is when I have sines and cosines, then 1 is equal to sine squared u plus cosine squared u minus sine squared u all over cosine of u times 1 plus sine of u. And then sine squared u's actually zero out. So I'm left with cosine squared u all over cosine of u times 1 plus sine of u. So cosine squared u is cosine of u times cosine of u. And then we have the denominator here. So then cosine of u divides out. So I'm left with cosine of u all over 1 plus sine of u. And that's what I want it to show. So therefore, the identity is verified. All right. So again, I really hope that you are enjoying this type of problem here, because we only have 2 more to go. All right, problem M. All right, so problem M. And again, there are lots of techniques for verifying identities, but I've been using some of the same techniques over and over again, primarily so that I show you that the techniques always work. All right, and that you're not thinking that I'm doing any sort of magic, because I'm not. All right, if I see a shortcut, I personally would take it, but I don't expect you to necessarily see the shortcut, especially when you are starting out doing these for some of your first times. All right, so let's look at this one, and I'm going to just start with the same technique as usual of changing to sines and cosines. So the secant of theta is 1 over cosine of theta, then a double fraction 1 plus 1 over cosine of theta. And then in the denominator, I'll write this as 1 over 1 and then multiply by cosine of theta over cosine of theta, so that I will have a common denominator in the denominator here. So in the numerator, I have 1 over cosine of theta. And then remember, this is a double fraction here, so I'm going to be extra careful about this, because at some point I am going to multiply by the reciprocal. So I want to make sure that I treat that fraction bar like a grouping symbol and put parentheses around the numerator and parentheses around the denominator. All right. So I have cosine of theta plus 1 over cosine of theta. So again, this is the point where I'm going to multiply by the reciprocal. So I have, all right, 1 over cosine of theta times cosine of theta over, all right, cosine of theta plus 1. So here, the cosine of thetas divide out, and I'm left with 1 over cosine of theta plus 1. Now, let's multiply by, all right, the conjugate here. Cosine of theta minus 1. Cosine of theta minus 1. All right. Now, again, it doesn't really matter if you do it that way, or better yet, all right, I could have, before I multiplied by the conjugate, instead of writing cosine of theta plus 1, I could write 1 plus cosine of theta, and then multiply by 1 minus cosine of theta, 1 minus cosine of theta. It doesn't matter which way. Which way do you think I'm going to do for this one? Probably the second one, because I see 1 minus cosine of theta is what I need in the denominator. Sorry, to make a conjugate here, but it's what's in the numerator of what I'm trying to verify. All right. So now, all right, the numerator, 1 times 1 minus cosine of theta, 1 minus cosine of theta. The denominator, distribute 1 minus cosine of theta plus cosine of theta minus cosine squared theta. And then the cosine of theta zero out. So we have in the numerator 1 minus cosine of theta over 1 minus, and then that in the denominator 1 minus cosine squared theta. Now again, for sines and cosines, a 1, right, can be written as, let's see, what can it be written as? Well, sine squared theta plus cosine squared theta, and then that's still minus cosine squared theta. And then the cosine squared thetas zero out. So then what am I left with? Well, I'm left with what I was supposed to verify, 1 minus cosine of theta over sine squared theta. So therefore, the identity is verified. I'm enjoying this. I really hope that you are also, because now we're down to the very last problem of the video here. All right, so hopefully you're getting a good sense of the types of techniques that you can use. So problem N, 1 plus sine of theta over 1 minus sine of theta is equal to secant of theta plus tangent of theta all squared. All right, now this one actually might be one that you think is a little bit harder to deal with at first, but let's do it anyway. All right, so I'm going to multiply by the conjugate of the denominator. So 1 plus sine of theta, 1 plus sine of theta. So in the numerator, I have 1 plus sine of theta squared, denominator 1 plus sine of theta minus sine of theta minus sine squared theta. All right, so then the sine of theta zero out. So I'm left with, in the denominator, right? So in the numerator, 1 plus sine of theta all squared, denominator 1 minus sine squared theta. But now remember, a 1 is equal to sine squared theta plus cosine squared theta. So I have 1 plus sine of theta squared over sine squared theta plus cosine squared theta minus sine squared theta. And then the sine squared thetas zero out. So we have 1 plus sine of theta all squared all over cosine of theta squared, or cosine squared theta. But again, as I just alluded to, that cosine squared theta can be written as cosine of theta squared. And then you see how the numerator and the denominator are both the quantity squared, right? So then I could actually rewrite this as, using the rules of exponents, 1 plus sine of theta all over cosine of theta squared. And then I'll break this into two fractions as 1 over cosine of theta plus sine of theta over cosine of theta squared. And then I'll use the trig identities. All right, so the reciprocal identity, 1 over cosine of theta, that's equal to secant of theta, and the quotient identity, sine of theta over cosine of theta is equal to tangent of theta, and that's all squared, and that's what I want it to verify. So therefore, the identity is verified. All right, so I verified that identity. So unfortunately, those are all the identities that I have for you in this video. So I hope you enjoyed that, and thank you and have a great day.